You're welcome to ekidel.com, where future leaders come to improve their knowledge.
Hello, welcome to Ekidel. My name is Justice Nwaka. I am your instructor. Today, we will be learning how to add wind load or wind effect to our building model in Protastructure. So, looking at this building, this is a 7-story building having a height of 28.2 meters. So, at this height, wind is meant to affect this structure. So, when you have a structure that is more than 10 meters high, you should be expecting wind to affect your structure. So at that point, you will have to add wind effect or the wind load to that structure, which will be added to the structural columns, which can take care of any adverse wind that can happen in the terrain or in the surrounding where your structure will be sited. So to add our wind load to this 7-story building, we will click on Analysis tab, and then we'll go to Building Analysis, and then we will click on Wind and Story Loads, and then we will click on Wind Load Calculator, and we will be shown a dialog box. Now, everything you need to know about the wind load depends on this dialog box. Whatever thing you add here is what the structure is, the effect of the wind the structure can withstand. So, looking at this first, we see I've seen a parameter at this area. Now, click on parameters, and you see the basic wind parameters. Now, basic wind speed, which is measured in meter per second. Now, this is the speed of the wind. Now, to get this value, you will either meet your weather scientist to get the values, or you will meet your urban and regional planning in your state or in your country where you are, or in the region where this building is to be sited, or where a building is to be sited. So you meet the urban and regional planning. They will give you the wind speed of the area or of that state or the area or the region or the terrain where your building is to be sited. Then, but for this structure, the wind load for this structure is 55 meter per second. This is the highest wind speed or wind effect that have occurred in this area where this building is to be sited. So it is 55. So I'm using 55 meter per second wind speed. The next thing is to impute the minimum wind speed, which is measured in kilopascal or kilonewton. So the minimum wind speed, the minimum wind effect or wind speed in this area where this building is sited is 0.74 kilopascal or kilonewton. Then the primary angle, you cannot measure the angle at which a wind go. So because wind goes in different direction, different angles, you can't tell which direction a wind is going. So, or you can't tell which direction a wind is affecting the structure. So you just keep the wind angle at 0 degree. So the next thing now is the terrain and the surrounding. Now, this terrain and the surrounding, it is you that will have to make a proper investigation of the site where this building is to be sited. Now, this building is a 7-story building having a height of 28.2 meters. Now, at this point, you will have to go and check the area if this building is the highest building in height within that terrain as at the moment at the time when you're about to build this structure. So if this building is the highest in height compared to all the buildings in that area, then that is only where you have to start keying in these values. That will give you an idea of what to key these values in. Now let me just explain this terrain and this surrounding explains more on this image and on this box. So now this is the building, a sample of the building. Now the distance, you can see this XO. This XO is the distance from your building to the next building. So what is the distance of your building to the next building or obstacle or trees? Are there trees around the place or around the building? If there are trees around the site where you're meant to site the building, then you have to put the height of the tree. I will not say you should go and measure the height of the tree, but you can use your eye to know the height, to assume the height of the tree. Or if it's a building, you can know how many stories is of the building. With that, you can now know the height of the building to put. Now, this X is the distance. What is the distance of the obstacle, either tree or a building, to your own building? Now, in my own scenario, we don't have any building on that area because all we have are trees. Trees are what we have because this building is to be built close to a forest, and in that area there are buildings that are very far away. So we don't have a any building structure close to this building in particular. All what you have are trees. So now, but the distance from the tree that we have to the place, to the point where this building is sited, which is XO. The distance is 15 meters. So you put the distance of the nearest obstacle to your building. So this XO is the distance of the nearest obstacle, either tree or building, to the building that you are about to site on the surrounding. Then the next thing we have here is HO. HO is the height. What is the height of that obstacle? What is the height of that tree? What is the height of that building? If your building is 21 stories or 20 stories, what is the next building? What is the height of the next building close to your building that you're about to erect? So if the height is let's say the height, let me say our own is 28.2 meters, and let me say the nearest building there is 3-story building, which is ranging around 10 meters to 9 meters. Now, but on this on my own scenario, what we have is just trees, and the tallest tree there from my eye gauge is not above 2-story building. So, and 2-story building, we all know 2-story building is ranging from 6 meters to 8 meters. So I use 8.5 meters. So 8.5 meters is the highest obstacle, that is closer to my, is the height of the highest obstacle closer to my building, which I'm trying to erect. That's what I'm designing for. So that is the highest height of obstacle closer to my building. The next thing there is delta X, which is the site altitude or relative level to sea level. Now, what is the height? If you measure from the height where you have a sea to your building, what is the height of the level? Now, on this place now, we have a sea over 1 mile close to this building. So the height of that sea 1 mile to this building, we have 150 meters high. So, but on these two values, which is the sea level and the distance to sea upwind, if you don't have a sea closer to your building, you can just leave these values as 100. But if a sea is closer to your building, then I would say you do a proper measurement or intuition to get the at least closest value which you can impute. So my case here is 150, and then the distance to sea upwind, I'll leave it as 100 as default. Then the site type. How is the site? Is it a country or a town? This country simply means that, what country here means that is that if you choose a country simply means that your building is sited on a place where people are not living that much. Just like let me say a farmland area, a place closer to the forest region. Now, if you choose a town is a place where other buildings are existing, people are living, where is occupied mostly by buildings. Now, in my own case, it's a country because it's what I have on that area as at the moment I want to erect my building is trees. It's trees and forests. So I'll quickly use country. Now the next thing to choose is to choose your wind code. What code are you using to design your building? For this case, we are designing this building in Nigeria, and then the code we use in Nigeria is British Code of Practice, which is the BS code, and the code for wind speed is, or the code for wind in BS is BS 6399 part 2 1997. So I'll quickly choose BS 6399 1997, and then after you're done with all you're doing, you now click on apply. Automatically this applies the wind load from the first story, which is story 1, to the last story, which is the story 8, which is the roof. Now you can see that the values are already imputed. Now you can now click OK, and then you can now begin to analyze your structure. We have already done analysis. maybe you watch the next video for analysis. This video is just to show you how to apply your wind load, and then you close. So with this is how to apply your wind load to your structure. Now automatically this structure now can withstand a wind speed or a wind effect of 55 meters per second. So this structure is safe against wind speed. This is how you apply your wind load or wind speed on your building while designing with Protastructure. Thank you.